day everyone, myself Dr. M. Karthigaiselvi, Assistant Professor of Computer Science, the Standard Fireworks Rajasthan College for Women, Sivagasi. Today we are going to explain one of the most foundational topics in cloud computing, the cloud models. Understanding this model is essential because they define both what kind of cloud service is provided and how that service is deployed. This topic is especially relevant for those pursuing careers in software development, system architecture, IT management or cloud administration. Cloud service models, which are often abbreviated as SPI, standing for SaaS, PaaS and IaaS. Let's begin with the service models. First, the most fundamental layer of cloud service model is IaaS. It is especially its main purpose of this is to deliver the virtualized computing resources over the internet. This includes essential services like virtual machines, storage volumes, load balancers and networking components. The goal of it is to provide users with raw computing power they need without the burden of owning or maintaining physical hardware. In this model, you rent infrastructure from the cloud provider, but you manage the operating system, applications and data that run on top of it. The provider handles the virtualization layer, physical servers, storage and networking. Some of the core features of it include self-service provisioning, which means user can spin up resources on demand through a web interface or a API. It is also highly scalable, allowing you to scale up or down depending on workload requirements. The pricing model is typically pay as you go, which means you are billed only for the resources you use. To put this in context, think of services like Amazon EC2, Google Compute Engine or Microsoft Azure Virtual Machine. When you launch a virtual machine through these platforms, you choose the operating system, you install the software and you configure the environment just as you would on the physical server, except you don't own the hardware. And the biggest benefit of this model is complete control. You design the configuration, the operating system, the installed tools, everything. You also avoid the upfront cost of purchasing hardware and you benefit from the flexibility to scale your infrastructure to match the changing demands of your applications. It's a great choice for organizations with dynamic workloads or those experimenting with different environments. However, it is not without its challenges because you are responsible for the operating system and all installed software. It requires certain level of technical expertise to manage and secure. You must handle software updates, batches, firewalls and monitoring. Moreover, if you don't manage resources efficiently, cost can rise quickly, especially in large scale or long running deployments. It is widely used in variety of scenarios. It is commonly chosen for hosting web applications, especially when performance and customizability are important. It is also suitable for testing and development environments, where the developers may need to quickly launch and discard resources. Additionally, it supports enterprise-grade workloads such as databases, analytics platform or ERP system. And it's useful for backup and disaster recovery strategies due to its scalability and remote access. Let's continue our exploration of cloud service models by looking at platform as a service, commonly abbreviated as PaaS. This model is especially important for software developers and team working on application delivery in the cloud. The cloud provider takes care of the infrastructure, operating system, middleware and runtime environment, allowing the developers to focus only on writing and running code. One of the powerful features of this model is support for multiple programming languages and frameworks. Whether you are working with Java, Python, .NET, Ruby or PHP, most PaaS solutions offer flexibility and compatibility. Furthermore, platforms often include automated scalability, load balancing and monitoring tools to ensure your applications run smoothly. Even as demand grows, this built-in functionality significantly reduces the time and complexity of deploying and managing applications. Examples of these models offering include Google App Engine, Microsoft Azure App Service, Red Hat OpenShift. In each of these platforms, you typically just upload your code or connect a source repo stream, and the platform handles the rest, including the provisioning resources, deploying the application and even managing updates. The benefits of PaaS are especially appealing in modern development workflow. First, it accelerates application development by abstracting away infrastructure related tasks. Teams can move from prototype to production more quickly. Second, this model enhances the collaboration by integrating tools for version control, continuous integration and delivery. However, it is also important to acknowledge the limitation of PaaS. Because the environment is managed by the provider, users have less control over how things are configured at the system level. This can be a platform for applications that need custom configuration, special security policies or very specific hardware requirements. Another concern is vendor lock-in. Once you build an application tied closely to a specific platform's architecture and services, migrating to another provider can be challenging. Additionally, legacy applications which were not built with modern cloud architecture in mind often do not adapt well to these environments. Despite these limitations, it is incredibly useful in wide range of use cases. It is ideal for web and mobile application development, especially when rapid deployment and frequent updates are needed. It also works well for API development and integration, and for projects that use microservices architecture. And because most platforms offer built-in tools for continuous integration and delivery, let us turn our attention to the software as a service SaaS model, the most visible and widely used layer in the cloud service model hierarchy. It is a model where fully functional software applications are delivered to end users via the web. The applications are centrally hosted by a cloud provider and are accessed through a web browser or mobile app, typically on a subscription or pay as you go basis. As a user, you don't have to worry about installation, system updates, hardware compatibility or software maintenance. All of that is handled by the provider. The key features of this model is mainly ideal for business and individual alike. First, there is no need for local installation. Everything runs on the provider's infrastructure and users access it remotely. This makes the applications platform independent and usable on almost any device. Second, this model uses a multi-tenant architecture, meaning multiple users share the same infrastructure and code base, but their data is securely separated. This allows providers to efficiently serve many customers at once. Additionally, automatic updates and batches are applied by the provider, ensuring that all users always have access to the latest features and security improvements. Some of the most well-known platforms include Gmail, Microsoft Office 365, Salesforce CRM, and Dropbox. These services demonstrate what makes us so attractive. They are easy to access, easy to use, and immediately available to anyone with an internet connection. Whether you are sending emails, collaborating on documents, or managing customer data, you can do it all from the browser without installing anything on your device. And these are the several compelling benefits to adopting SaaS. For organization, the most obvious is cost reduction. There is no need for hardware purchases, in-house maintenance teams, or software licenses for each employee. It is also highly scalable. Companies can start with a few users and scale up to thousands as they grow, simply by adjusting their subscription. Because applications are cloud hosted, they can be accessed anytime and from anywhere, promoting collaboration and remote work. However, like all technologies, SaaS is not without its limitations. Since the software is hosted by a third party, customization options are limited. Users often have to adapt their workflows to fit the software rather than tailoring the software to their needs. Additionally, there are data privacy concerns, especially for organizations handling sensitive or regulated data, because the data resides on external servers. Internet dependency is another drawback. If connectivity is lost, access to the software is interrupted, which can be critical for some business. Despite these challenges, it is incredibly well suited to a wide range of use cases. It powers email and communication tools like Gmail and Outlook, customer relationship management systems like Salesforce, enterprise resource planning, tools for managing finance and operations, and collaborating platforms like Google Drive and Microsoft Teams. To conclude, IaaS, PaaS, and SaaS offer different levels of cloud service and user responsibility. IaaS gives full control over the infrastructure and ideal for system administrators. PaaS simplifies application development by handling the environment setup. SaaS delivers ready-to-use software with minimal user management. As we move from IaaS to SaaS, user control decreases while ease of use increases. The choice between them depends on the organization need for flexibility, control, technical expertise, and convenience. Understanding these models helps in making smart, cost-effective cloud decisions. Thank you, friends. Thank you for watching this video. Thank you.